Hello students, hope you all are fine. Let's start integration by trigonometry. How to use trigonometry to integrate some function? Let us start with some examples. Suppose we have the integration in this form, I equal to integration of sine cube 2x plus 1 dx. Then here we have sine cube. That means you have some cubic function in terms of trigonometry. We have to reduce this cubic function to some linear one. Then only we can do the integration. And to convert the cubic function to a linear, we must use some trigonometric identities. Not only cubic, it may be some square functions, it may be some product functions, it may be some rational functions in terms of trigonometry. All these functions we need to convert to a linear function, then only we can do the integration. And to convert it, we need to use the trigonometric formula. Here, sine cube 2x plus 1. That means this sine cube I can use, this is as sine square 2x plus 1 into sine 2x plus 1 dx. So that means integration of sine square 2x plus 1 into sine 2x plus 1 dx. This sine square I can write as 1 minus cos square 2x plus 1 into sine 2x plus 1 dx. That means here now if I put t equal to some cos 2x plus 1, simply dt become, that is minus of sine 2x plus 1, and for this 2x plus 1 we get 2 here. That means this implies you must have minus 1 by 2 dt equal to sine 2x plus 1 dx. You must have on dx here also, like this, minus 1 by 2 dt equal to sine 2x plus 1 dx. Now look here, our integration changed to I equal to integration of, this is 1 minus cos square, cos is that taken as t, that means it is t square, into, that is sine 2x plus 1 dx. Sine 2x plus 1 dx is minus 1 by 2 dt, that is minus 1 by 2 and dt. See, I have converted in the known form of integration by using this trigonometry. This way you can do it. Not necessarily by simply sine square 2x, sine 2x plus 1. We can expand this sine cube by sine 3x formula. Like you have sine 3x, you can write 3 sine x minus 4 sine cube x. From here 3 sine x equal to 3 sine x equal to 3 sine x minus 4 sine cube x. From here you can calculate sine cube x. How? Simply you take, replacing this 4 sine cube x, 3 sine x minus sine 3x, and this implies sine cube x equal to 3 sine x minus sine 3x full divided by 4. So that means sine cube x also can be written in this form. So that means your target is to convert the cubic function or a square function or any product function or any rational functions in terms of trigonometry in a linear function, because we know the integration of linear trigonometric functions. Okay, dear students, so this way now you can do the integration over it. That is simple one. I think you can do of your own. That means even though that is 1 by 2 as it is, and this part after doing integration you get simply t, and here you will go t cube by 3, and this is c. Now replace your t by cos 2x plus 1, and that is the, after replacing, that will be your answer. Okay dear students, not only this, any types of question, I show you one more how we can change or how we can use trigonometry to change the given function to a linear form, so that we can do the integration over it. Let's start one more problem. Look here, we have I equal to integration of cos 2x, cos 4x, cos 6x. That means we have the product of three trigonometric functions. Now, how can we make it a linear one? Simply, we have to use some trigonometric formula over it. What trigonometric formula you can use? We can use the formula 2 cos x cos y formula. Do you remember the 2 cos x cos y formula? 2 cos x cos y equal to cos x plus y plus cos x minus y. That formula, see, 2 cos x cos y can be written as cos x plus y plus cos x minus y. If you replace this one by this one, then it can be a linear function. Let's check how. 2 cos x cos y, but here we have no 2. That means I have to multiply 2, also divide by same 2. That means here I am giving 1 by 2 integration of 2 cos 2x, cos 4x and cos 6x dx. That is equal to 1 by 2. Now this is integration over this cos 2x and cos 4x. Over this part I use the formula, this one, cos x plus y plus cos x minus y. Okay, so I keep 6 cos 6x as it is. Then over it I use the formula cos, that is cos 2x plus 4x, okay, and then plus cos 2x minus of 4x, okay, that is equal to 1 by 2 integration of cos 6x, this part become cos 6x, this part become cos of minus 2x. Cos of minus 2x is cos 2x. That means cos 2x. Here I close my bracket, and that is equal to 1 by 2 integration over, that is cos 6x means it is cos square 6x. And here you have cos 6x cos 2x. Okay dear students, I think I am clear to you. This is cos 6x into cos 6x, that is cos square 6x, plus this plus is here, and cos 6x into cos 2x, that is cos 6x into cos 2x. Now again here, look here, cos square 6x, that I can use cos square formula. Cos square formula I can use. See, cos square x can be written as, cos square x can be written as, cos square x can be written as 1 plus cos 2x by 2. Cos square x can be written as 1 plus cos 2x by 2. So that means this part I can change as, 1 by 2 integration, that is cos square 6x. Cos square 6x can be written as 1 by cos 12x divided by 2 plus, again I am multiplying 2 here, that means cos 6x cos 6x, cos 2x, full divided by 2, and over this we have dx. Now I take this 1 by 2 common from these two terms and take it out. That means we have 1 by 4 out and integration over, that is 1 plus cos 12x, and here again what we can do, 2 cos x cos y. 2 cos x cos y means that is cos x plus y, that is 6 plus 2x, that is 8x, and cos x plus cos x minus y, that is cos 6 minus 2x, that is 4x, and dx. Now see, every term is linear and every term is integrable, and we can take very easily the integration of these terms. Like what we can have now, that is 1 by 4 integration, that is integration of 1, that means simply you get x, integration of cos 12x. Cos 12x is sin 12x by 12 plus cos 8x, that is sin 8x by 8, and cos 4x, that is sin 4x by 4, and plus c. That is your final answer. You can multiply this 1 by 4 to all these terms also, then you can get the final answer. Otherwise, okay, one more thing, I can multiply after doing this integration. I get x plus sin 12x by 12 plus sin 8x by 8 plus sin 4x by 4 and plus c. Now I can multiply this 1 by 4 to all these terms. Okay, and you can get the final answer. So this way, look here, when the terms are given in form product, how I converted it to a linear form? By using trigonometry. Simply I use the formula 2 cos x cos y. Likewise, so many questions will be there in your exercise and you can go through this. You have to use the formula. Here I use the formula 2 cos x cos y. Sometimes you may use the formula 2 sin x sin y, 2 cos x sin y, or 2 sin x cos y. Like this, all the formulas can be used as per the requirement of the question. Okay, dear students, now let's move to the another type of problem. Let's see. Let I equal to integration of 1 minus cos x divided by 1 plus cos x. This is a very simple one. Simply you can use the trigonometric formula and get your result within a very few seconds, few minutes. That means here integration 1 minus cos x. 1 minus cos x, what we can write? That is 1 minus cos x can be written as, see, sin 2x. What is sin 2x? Sin 2x is sin 2x is 2 sin x cos x. What is cos 2x? Cos 2x equal to either it is cos square x minus sin square x, or it will be 1 minus 2 sin square x, or it will be 2 cos square x minus 1. Okay, from this part we can get, that is 1 minus cos 2x formula. How? Simply you transfer these terms to here, that will give you, look here, if I transfer this term, that means 2 sin square x equal to cos 1 minus cos 2x. 1 minus cos 2x. So this implies 2 sin square x equal to 1 minus cos 2x. 1 minus cos x. That means here the angle is double. and here the angle is half. So that means here it is double, that means we can write it as 2 sine square x by 2. By using this one and this one, by using cos 2x equal to 2 cos square x minus 1, what you will get? You will get this one, that is 2 cos square x by 2, and dx is here. These two will cancel out. Sine square x by cos square x, that we all know, that is nothing but the tan square x, tan square not x by 2 dx. Now tan square x, I want to ask you, dear students, do you know the integration of tan square x? I think your answer will be no. We know the integration of tan x, not the integration of tan square x. That means we have to change this also. Tan square x we can write as sec square x by 2 minus 1. That means integration of this is sec square x by 2 minus 1 and dx. So now it is in the integrable form. Sec square x, integration of sec square x, that we all know, that is tan, and 1 that is known to us. So finally we get the answer as this is sec square x by 2, that is tan x by 2, and for this x by 2 we must have 1 by 2 here, and minus 1, and that is x plus c. So your answer will be 2 tan x by 2 minus x plus c. That is the final answer of this question. 2 tan x by 2 minus x plus c. Okay, am I clear? Okay, so this type of problem, whenever you have 1 minus cos x or 1 plus cos x, you have to replace this by this formula, 2 sine square x by 2 and 2 cos square x by 2. Okay, dear student, and how we got it? You simply cos 2x formula, you got it. Simply by using cos 2x formula. Let's see one more type problem. Integration of cos 2x minus cos 2 alpha full divided by cos x minus cos alpha, cos x minus cos alpha dx, that is equal to integration of cos 2x. Cos 2x can be written as 2 cos square x minus 1, and minus, again I can write 2 cos square alpha minus 1 full divided by cos x minus cos alpha, and it will be kept within this bracket, and we have dx out of this bracket. So this is equal to integration 2 cos square x minus 1 minus 2 cos square x and plus 1. This plus 1 minus 1 we can cancel out. Remaining part, that is 2 cos square x and minus of 2 cos square alpha divided by cos x minus cos alpha and dx. See, anyhow, by using this formula, cos 2x formula, what we did, that is cos square x minus 2 cos square alpha. I want to convert the numerator in this form. Wow, why? Because so that I can cancel it out. That means here you can take these 2 common out, that is 2 integration of cos square x minus cos square alpha divided by cos x minus cos alpha. So here we have cos square x minus cos square alpha divided by cos x minus cos alpha. Here we can use a square minus b square formula, that is a plus b into a minus b, and after getting that you will get your integrand as cos x plus cos alpha and dx only. After expanding this one, I cancelled it out with it. Okay, now cos x plus cos alpha, now it is integrable form, and integration of this will be 2 integration of 2 integration of cos x is of sin x, and plus 2 is here, I put 2 also here, cos alpha. Dear student, many of you may do some mistake over here that this cos alpha you treat as a variable, but it is not a variable. It is a constant. So we don't do anything over it. You simply cos alpha keep as it is, and as there is nothing, no derivatives or no variable, so your variable will be here simply x. That means I am keeping here, that is x, that is 2x plus cos alpha, and plus c, you must put c here. So that is the answer. Okay, dear students, like way you can find the integrations of some functions by using trigonometry. By using trigonometry, your problem become very much simpler. So let us proceed to the some more type problems, and some more type problem depend upon some 6 standard formula. Our next part will be 6th standard formula of integration. Let's check one by one. Okay, dear students, let's see some standard results of integration. Number 1, integration of dx by x square minus a square. See, x square minus a square, that means you can apply a square minus b square form here. So that means you can write it as integration of dx upon x minus a into x plus a. Now I want to make two separate terms. Let's see how can we make it integration. I write simply 1 upon x minus a minus 1 upon x plus a. So this is dx. So now look here, x plus a minus x minus of a, that means you will get 2a. In the numerator you will get 2a, and that 2a we can cancel it over here. So you will get the same thing only. So that means 1 by 2a and integration of 1 by x minus a, you can write it as log of x minus a and minus log of x plus a. That means 1 by 2a log of x minus a by x plus a, by using the property of log, and plus c. So this is the standard form. This is the standard form of this formula. Look here, integration of dx by x square minus a square can be written as 1 by 2a log of x minus a by divided by x plus a plus c. So you have to remember it, or you have to calculate this integration. So we will have 1 by 2a log of x minus a by x plus a. And for the same thing only, here dx upon x square minus a square, just interchanging x and a, that means dx by a square minus x square, and that will give you 1 by 2a log of a plus x divided by a minus of x plus c. Similarly, by how we get it? Same way, same method as I have shown. Here what to do? Simply you will get 1 by a tan inverse of x by a plus c. So that means How we got it? You can replace this x square by, simply we can replace this x by a tan theta. A tan theta. That means a tan theta means that is x by a tan theta. Or this implies theta equal to tan inverse of x by a. Now if I replace this part using this a tan theta, so what happened? Integration dx upon, that is x square plus a square, that is a square tan square theta plus a square. Now take this a square out, that means 1 upon a square dx upon, that is, we have to change this dx also. Dx means it will give us, dx also give us a sec square theta. Now we replace this dx as a sec square theta, that is a sec square theta d theta. And here after taking common this a square, you will have a sec square theta in the denominator also. That is sec square theta will cancel out. So remaining will be only d theta, and the integration will be only 1 by a square and theta. And 1 by a square theta means that is theta. Here will be theta. Theta equal to tan inverse of x by a. So this a will cancel out. So only 1 a will be there. So answer will be 1 by a tan inverse x by a plus c. So this way you can find the integration of this one and this one as well. So integration of this part will give you 1 sine inverse x by a. And integration of this part, here simply we put a x square equal to a sine theta, and after calculating in the same procedure you will get 1 by a sine inverse x by a plus c. So this will be the answer of this one. And the fifth one, here x square minus a square, we put x equal to a sec theta. A sec theta, and that will, after calculation, that will give you, or you can get log of x plus under root of x square minus a square plus c. That will be the standard one. Likewise, whenever you perform this integration, what do we do? Again we put x equal to some tan theta, and that will give you log of x plus under root of x square plus a square plus c. So this way you can do the integration of these standard functions. These standard functions we use while performing integrations of some different functions. So dear students, I think you have enjoyed today's lesson, and I think you are doing regular practice and you are getting interest over this integration. So let's conclude here. In the next class we come with some different formula and different questions on integration. Thank you.